My name's Jessica Michael, and I'm a PhD candidate from Monash University and the Epworth Centre for Innovation in Mental Health. And I'm here today to talk about transdiagnostic EEG correlates of attentional control in anxiety, systematic review and implications for treatment development. So up to 1/3 of the population will have an anxiety disorder in their lifetime. And current treatments are largely ineffective with moderate effects at best. So new approaches are urgently needed. Given the high levels of comorbidities between anxiety disorders, this has led to the development of transdiagnostic models, whereby more focus is given to the commonalities found across disorders as opposed to their differences. An advantage of such models includes that they provide a framework to study the underlying mechanisms rather than the symptoms of disorders, which in turn may lead to more effective preventative and treatment approaches. So one potential transdiagnostic symptom in anxiety disorders is altered attentional control, which has been shown to occur across diagnoses and to be related to the onset and maintenance of anxiety. Attentional control refers to an individual's ability to pay attention to a wanted or required stimulus while ignoring all other stimuli. Poor attentional control encompasses the processes inherent in attentional bias, i.e., the tendency to focus on negative threat-related stimuli, and is believed to be linked to the phenomenon on hyperactive response monitoring. Hyperactive response monitoring has been implicated across clinical anxiety symptomology, namely as excessive worry and hyperarousal to mild stresses. So attentional control is believed to originate from the dorsolateral prefrontal cortex, with regulation by the anterior cingulate cortex, which is the source of response or conflict monitoring. Crucially, the specific brain activity thought to mediate attentional control can be recorded by electroencephalogram or EEG. Event-related potentials are an electrophysiological response to a stimulus, which can be recorded by EEG. These include error-related negativity, or the ERN, and correct response negativity, or the CRN. The ERN is a type of event-related potential reflecting a response-locked negative deflection, which only occurs when a behavioral error is made, as can be seen on the peak in this image here. Similarly, the CRN is a smaller ERN-like response that occurs in the presence of a correct response or in the absence of an error. By examining markers of attentional control, such as the ERN and the CRN as they relate to clinical anxiety, we may gain a better understanding of the pathophysiology underlying anxiety, which could have real-world implications for the treatment development of clinical anxiety. So therefore, the aim of the systematic review was to examine attentional control studies, comparing differences in the ERN and CRN in individuals with anxiety disorders compared to healthy controls. A comprehensive literature search was conducted for studies published prior to October 22nd, 2020, across 4 databases. Studies were included if they matched all 3 a priori criteria. That is, if 1, attentional control was measured using one or both of the ERN and the CRN. 2, individuals with clinical anxiety were part of the study sample. And 3, there were original research published in peer-reviewed journals and written in English. Reviews, systematic reviews, and meta-analyses were excluded. So as you can see here, after 2 screening phases, 66 papers remained and had their data extracted. So all 66 studies measured the ERN, with 85% finding significantly increased ERN amplitudes associated with clinical anxiety. Only 44 of the extracted studies analysed the CRN, and only 20% of these found significant changes in CRN amplitude associated with individuals with clinical anxiety. So together, this provides strong evidence that an increased ERN amplitude appears to be a trait marker of clinical anxiety, which is consistent transdiagnostically and across the lifespan from children to teenagers to adults. This is in line with findings indicating increased response monitoring and a greater emphasis on errors in people with clinical anxiety. However, future research will need to verify this in older adults, aged 60 plus years old, and in anxiety disorders that weren't as well represented by the extracted studies, such as selective mutism. Additionally, there is good evidence that an increased ERN amplitude may be a good contender for a susceptibility marker of clinical anxiety in children and teenagers, given current longitudinal data. However, further research is needed to explore this in adult populations. Whilst there is good evidence of the ERN as a trait marker of clinical anxiety, we, however, at this stage cannot go as far as to call the ERN a diagnostic marker of clinical anxiety, as no extracted studies explored the specificity, sensitivity, or incremental validity of the ERN in this context. The current evidence of the ERN as a marker of treatment response is mixed and is highly dependent on the treatment modality. However, it is promising in the context of brain stimulation approaches. Therefore, future research should continue to investigate the possibility that the ERN may also act as a marker of treatment response. If relevant, such findings could assist in further uncovering the mechanisms between clinical anxiety and attentional control and may aid in the development of novel treatment approaches. The interpretation of ERN as a transdiagnostic trait marker of clinical anxiety may be limited by three main past findings. One, that the ERN is sensitive to state-specific manipulations such as caffeine and monetary incentive. Two, that the ERN is related to other cognitive constructs such as working memory. And three, that the ERN may be related to other psychological disorders not related to anxiety. This suggests that perhaps the ERN should not be considered in isolation and should be examined together with other markers in order to strengthen its specificity. Therefore, the ERN has potential as a transdiagnostic marker of treatment response as part of an array of measures. We are now conducting a study investigating whether theta TACS, as theta oscillations have convergent links to both attentional control and anxiety, can improve attentional control across the anxiety spectrum, measuring both behavioral and EEG-related outcomes, including the ERN. This will be an intervention study looking at the effects of brain stimulation on brain stimulation outcomes, with the ERN included for measuring target engagement. So stay tuned to hear about our future findings. So references. Thank you very much for listening.
Okay, thank you, Jessica, and thanks for starting your presentation without any prompt. It was very helpful because I was a bit late, and then yeah. So anyway, my name is Hakue Fujiyama. I am chairing this session. So welcome everyone. So just before, sorry for the question, I just need to do a bit of housekeeping. So we have 8 minutes presentation followed by 2 minutes of question and answer. And then please stick with the time. So, and if you have any questions, please post it on to FOBA Q&A feature, not the Zoom chat function. Okay. So anyone have any question? Maybe I will kick off. So Jessica, it was a really valuable studies you presented today. And I'm just wondering if you can tell us a bit more about the intervention study you've started. For example, which part of the brain you're stimulating, like what kind of montage you're using. So if you can provide us with a bit more details about the current experiment, that'll be interesting.
No worries at all. So I'll just go back to this slide. So this is our montage here. So we're targeting the medial frontal cortex, and it'll be 2 lots of 10-minute theta stimulation. So it's in 2 10-minute blocks, so we can measure resting EEG between the blocks because we want to see how theta activity changes after pre and post stimulation to see whether that theta power has any changes. So they'll be resting pre, mid, and post TACS. Then we'll also have the Simon task done during stimulation, which is meant to enhance attentional control. And then pre and post stimulation will also have the flanker task, which is where the ERN will be measured. So we'll be interested to see if we'll see any ERN amplitude changes.